After class last Monday, one of you stopped me on the campus and asked a question which I think would be a very valid place to start here today in the light of what we've done so far. Your question was, when we talked about Stonehenge and about the pyramids, isn't that science or is it technology? Well, it's a difficult question to answer in this respect, that science and technology are really twins. It's very hard at times to separate one completely from the other. But I would try to maybe I can do it this way today. The thing about Stonehenge and about the pyramids, we don't have any really valid presentation of what went into the construction of those and the theories on which those people at that time worked. In other words, we see the evidence of it. Here's Stonehenge and here are the pyramids. Did they know exactly how to go about this? Obviously, you say they must have, or they wouldn't have built them. But how much science went into it? Or was it just a, if you will, like a sleepwalker, coming up with an idea and let's try it? And you know, in science, we can show that many of the things which have developed have been just lucky breaks. Serendipity has played a very important part. So we're not sure, because these two cultures did not keep accurate records. So we can only surmise. But we do know that there's a lot of technology there. There's a lot of technology, obviously, in getting a man on the moon. Also, there were some scientific principles involved, and to separate them completely is difficult. So I'd answer your question this way, that the pyramids and Stonehenge represent some pretty good scientific ideas and bring out some definite ideas today that have helped us, but there was a profoundly sound technology that went into it. Now, the thing that I wanted to try to get at today, as a follow-up to that, is that the Greeks did keep records. We have much of their writing has been preserved. It was preserved by the Arabs in the period of the Dark Ages and then carried back over to Western culture. But in this period of, let me say it, and I'm guessing here, some of you may disagree with this, but I'll say that the Greek age of science, and here I'm taking an estimate of somewhere like this, about 650 BC up to about 200 BC. I think that period would encompass at least everything that I want to bring out here. Now, the Greeks had many varied facets to their ideas of what the world is like. And basically, all that science is, what I'd like to get across to is science is nothing more than an attempt to try to understand nature, try to come up with some answers. Now, we can do it, as you folks will find out as you go through the work that is devised for you, worked out for you this semester. We can do it by leaps of imagination, by what we call induction. Then we try to deduce certain consequences of those theories that we've developed. Now, the Greeks were at this, but the Greeks were not great experimenters. Now, in everything that we've done, I'm going to try to start out here today with what I'll call three schools of thought. And I've given some names to them which may or may not be apropos. The first one is a school that we ascribe primarily to Aristotle. And then there were two other people living at this same time, Ptolemy and Galen. Now these three people lived within the framework of this 650 BC to about 200 BC. They were quite early. They would go back in the 300 or 400 BC. Now, I don't know whether this is a good terminology, but I'm going to say that they represent what I'm going to call the organic concept. Then there would be another school of thought. I'll list all three of them, then we'll take up each one. The next one would be due primarily to Plato. And I'm going to call this the magician or the mystic or some term like this, and I'll try to explain it. I may not have good words here, but these are what I'm using temporarily. Then another one was that of Archimedes, and I'll call him the engineer. I think, and there are a number of other people I'd like to introduce if we have time, but certainly this would represent three very prominent, very important aspects. Now, in the case of Aristotle, they had the idea that everything is organic in this sense, that everything belongs, well, first of all, let me put it this way, that Aristotle believed definitely that there was a first cause, and this led to another, leads to a particular effect. Then this led to another cause, and ultimately down through infinite amount of time to a final, if you will, a final effect, which would be the end of this initial first cause. In other words, a cause and effect situation. Then Aristotle argues that in terms of this first cause and the effect that ensues, that there is a certain, all things, be they stones, human beings, wood, everything has a belonging. Everything belongs. Maybe I could put it this way, a sense of belonging. And they argued this way, that a stone, if lifted, it belongs in the earth. It belongs with Mother Earth. So if you were to pick up that stone and then drop it, it would return to the earth because that's where it wants to go. That's its most logical place to be. And then they can't, now here, they're not experimenting. This didn't come till hundreds of years later. But Aristotle said, for example, and some of his followers, that a heavy stone should want to return to the earth much faster than a lighter stone. So I might put it this way. If you had a stone that weighed 5 pounds and another stone that weighed 1 pound, and you put them up here at a certain distance from the earth, and you release them, the 5-pound stone would tend to get back to the earth 5 times as fast. Now they said this should be logical. Don't question it. Now they did not do any great amount of experimenting on it. Or if something is very light, it would tend to take a much longer time. If you take a feather and drop a feather, it would take it longer to reach the earth because it wants to get back to where it belongs. And so there's this sense of belonging and a feeling of responsibility, if you will. But there's a cause and an effect. Then Aristotle argues further that, now here he gets help from Ptolemy. Ptolemy was the astronomer. And very early in the game we became interested in astronomy. The Arabs, the Phoenicians, all of these people who sailed the Mediterranean were interested in how to get from here to there. And Ptolemy definitely was the astronomer who would be the, if you will, the contemporary working with Aristotle. Now he and Aristotle went along with this. They believed that the earth is the center of the solar system. We had a geocentered universe, if you will. Then the Greeks believed, if this represents the earth, the Greeks believed, I'll say that not all the Greeks, there were some who disagreed, but the followers of Aristotle and Ptolemy believed that the most perfect geometric form was the circle. So they argued, first of all, because we are human beings and we're the greatest of the initial creation. Now, they were pagans, to be sure, but they had an idea of a divinity. The reason that this earth must be the center is because the human beings live here. So that has to make it the most important part of this system. Then they believed, for example, that the moon and the sun and Mercury and Venus and Mars and Jupiter, so on, all traveled around the earth. And they all travel in perfect circles, because that's the most perfect form. Now, for example, 2, 3, 4, 5, 6, and I also might put Saturn. There were 7 celestial objects. The Earth is the center, then the Moon, the Sun, Mars, Venus, Mercury, Jupiter, and Saturn. A total of 7 objects revolving around the Earth, and 7 was the perfect number. The 7 occurs so many times in literature, in history, as one of the perfect numbers. In the throw of the die, the 7 is an important number. And Aristotle said 7 is perfect. First of all, you have 2 nostrils, you have 2 eyes, 2 ears, and a mouth. That adds up to 7. That's a perfect number. And he said, so did Ptolemy. Ptolemy would argue, don't try to find any more celestial objects, because 7 is the number and there won't be any. So now we take that for granted. Now here's where the Greeks had thought experiments. They came up with some wonderful things, but they didn't really test them out. Of course, at that time, they didn't have too much instrumentation to test them with. And furthermore, they didn't particularly want to. They didn't feel it was necessary. We might also mention that Galen worked out a system of medicine. And his book in medicine, we would call it quite a superstitious thing today, but yet it was the most profoundly authoritative book in medicine up until the 17th century almost, or at least a little bit before that. So we had these 3 people, Aristotle, Ptolemy, Galen, giving a concept of living which became a very dominant concept in the life of all the people. Now, there were some who disagreed. For example, now I better say this, that in Aristotle was a great observer, and he was particularly good in the field of biology. In fact, he wrote quite a good treatise on the nature of animals. He was a very careful, patient observer, but he did literally no experimentation. But we do give him credit for literally founding an important segment of science, namely biology. He was so very careful that in the course of his thinking about these, he developed a great love for logic. And he was a fair mathematician. Now, Aristotle felt that if we look at a thing and consider all aspects of it, we can argue very logically. Now, he favored, although here's something we'll want to get into, you folks I'm sure will discuss this, and it's pretty hard for me to say this is the way it is. But Aristotle developed the syllogism, and he tried to argue in terms of a very profoundly direct and non-controversial type of argument. And he said, if we look at enough cases, gather enough facts, if you will, we can use induction to lay down what we'll use the induction to form what we'll call a major premise. Now, in order to form that major premise, you have to have pretty good evidence. You want to be sure of your facts. Be sure that what you're saying will be accepted by all of you. You won't question it. That if you can then come up with this major premise, then you can use deductive logic and deduce logical consequences from it. This became the basis of what we call modern logic. Now, for example, we might say, we've looked at all people. We've made a very careful study, and we find that all men are mortal. Now, will you accept that? Well, if any of you said, no, I won't accept it, then we can't do you any good. But if I ask you in the room here, will you all accept the idea that all men are mortal? If you say yes, then I'll make that my major premise. And I'll say you accept that, because there seem to be no exceptions to it. Now then, I'll come back here and say this. Aristotle is a man. Well, we think we have pretty good evidence that that's true. Aristotle is a man. Therefore, now you deduce your conclusion. You say, okay, now we have to accept this. If we accept that as a valid statement, then we recognize that Aristotle is a man. Then I can deduce a logical conclusion and say, therefore, Aristotle is mortal. And you say, well, that makes sense. Now, that would be the type of thing that we're saying here. He was a great believer in being as careful. Try to think just as carefully as you can before you make a statement and draw a logical conclusion. Now, in the course of the years that followed, Euclid, Pythagoras, Aristotle, a number of them began to work with what we call geometry. And for example, let me give one more illustration. In order to progress, and this has to be true today as much as it was then, you have to be willing to accept something as valid. For example, if I say a straight line is the shortest distance between 2 points. Now, in the world in which we live, we'll say, or let's look at this tabletop. In other words, you say, well, that makes sense, and you did that in your plane geometry. You say, if I want to go from here to here on this tabletop, the straight line is the shortest distance to get there. So that would be something which you would say, that is an axiom. We will all accept that. There'll be no question. Now, on the other hand, if you're living on the planet Earth, which we are, and you try to go from New York to London, you can't go by a straight line. You follow the arc of a great circle. So we have to remember that these axiomatic things depend on the conditions under which we make them. But in the world of finite being, as we live today, this tabletop is flat. A straight line would be the shortest distance between 2 points on that table. So this type of thing came into being. And what I'm saying is that Aristotle, founding this school of thought, believed that everything had being. We are being. Everything belongs to this earth, to the part that we play. And everything has a certain relationship. There's a first cause and a final cause. Now this type of thing made it possible in the later years for the for the people in religion to more or less accept Aristotle. There was room for the religious principles. Aristotle became a pretty profound influence on future theological activity. Now, however, Plato died shortly. Well, actually, Aristotle studied under Plato or was with him quite a bit, but Plato was an older person, died soon, quite a bit before Aristotle. And I've called Plato the magician, for want of a better word, or a mystic. In other words, Plato had trouble with, he was, if you will, I should say this. Plato he was the poet. Much different than Aristotle, if you will. He had trouble with mathematics. He did use induction in forming ideas, but Plato, actually, I think we could argue this, that in much of his work, he would be more nearly one to use deduction. In other words, ideas, this poetic leap of imagination that comes every so often. This would be Plato. He would not be the hard and fast cause and effect man, but he would come up with ideas, and you might say, how do we get them? Let me put it this way. How did Einstein come up with the theory of relativity? Now, Einstein never worked in a laboratory. In fact, he wouldn't even honor a laboratory hardly to walk into it. He did what he called thought experiments, Gedanken experiments. He would rather sit in a chair and think of certain things, and he would come up with ideas. Now you might say, well, how did he get the ideas? He had to have some previous experience to work with. For example, he was very profoundly knowledgeable about the work of Max Planck and people who had worked before him. But he didn't take their data, if you will, per se, as we would up here in a chemistry lab or a physics lab. He thought about it in the quiet of his room, and he would come up with ideas which led ultimately to a theory of relativity. It was a poetic leap. Now, this question you folks probably will argue as time goes on. In other words, when I say the term poetic leap, does it mean that we're doing something that is purely a mental process? Let me ask it this way. Suppose I'll write just one very small part of the theory of relativity, that the energy of a system is equal to the mass times the square of the velocity of light. Now, how did Einstein come up with that? Well, he said, I was thinking about other people's experiments, and it just flashed into my mind after concentrated thinking. It was, I call it, a lot of people disagree with it, I call it a poetic leap. I say this thing right here, or when Sir Isaac Newton said the force of gravity is equal to a constant times the product of the masses divided by the square of the distance. How did he come up with that? This is Platonic leap, because Newton didn't experiment. Some say he sat out under a tree and watched an apple fall, and maybe it hit him on the head. We're not sure. But in any way, if he did see the apple, Newton says, I saw things being attracted to the earth, and then I began to wonder, what about the moon traveling around the earth? Does that have the same kind of forces? So he conjured up a thing called gravity, if you will. He could have called it by any other name. But now what I'm asking is this. Suppose that Einstein hadn't come up with that one little thing of this makes possible the atomic bomb, that very simple that very simple mathematical expression. This makes possible the plotting of the orbits of the planets around the sun. It had tremendous consequence. Now suppose that Einstein and Newton had not lived. Suppose, for example, that Beethoven had not lived. Let's say, for example, suppose that Michelangelo had not lived. Let me ask you this question. If Beethoven hadn't lived, I'll just grab one, would somebody else have written the Fifth Symphony as we know it today? If Michelangelo hadn't lived, would someone other than Michelangelo have sculptured out the David, said to be probably the greatest piece of sculpturing ever done? If Einstein hadn't lived, would someone else have come up with this? Or would you say, well, now I've had people say this to me, well, these are parts of nature. These are profoundly specific parts of nature. Therefore, if these men hadn't lived, somebody else would have come up with these. And that may or may not be true. Maybe we don't live, maybe, let me philosophically put it this way. Maybe if this had not been discovered by, or proposed by Newton, maybe we'd have some other kind of a universe. Or, let me put it again, what if some one of us were born in a spaceship, traveling at such velocity that there is no gravity? This wouldn't hold, would it? We'd be in a totally different kind of universe. But on the other hand, if Beethoven hadn't lived, would we have the Fifth Symphony? You might say, no, we never had that. Or would Shakespeare? What if Shakespeare hadn't lived? Would someone else have written, as we know it, say, Hamlet or Othello? And I don't know how you'd answer it. But nevertheless, these are some of the things that we try to consider in the philosophical aspect of all of these things that we are going to talk about. Now, finally, Archimedes. Now, Archimedes was one of the few Greeks that did experiments. For example, well, if you've studied some physics, you know Archimedes' principle, the buoyancy of an object in a displacement in water. He did quite a bit of work with the lever, with the lathe. However, he did not develop the lathe, but Pythagoras invented the lathe. But he did work, and Archimedes began to see the things of the universe as mechanical. In other words, the human hand is a mechanical part, and it's a system of levers, of fulcrum, and so on. And he began to sense this, so he was the engineer, if you will. And his work, Archimedes' work, definitely, all of these things were recorded. Now here's where the Greeks were different than the Egyptians. Yet all of the Greeks traveled to Egypt. They were all concerned with the work that the Egyptians had done and were doing, but well, maybe it's this way. Probably the Egyptians were very much theology bound in that all of the great ideas were held on to by the priests. All of the knowledge was held in the priesthood. The Druids, in the Druid culture of King Arthur and of that period of about 800 to 900 AD, only the priests, only the Druid priests had knowledge. The ordinary person did not gain an education. They got it from the priests. Now, the Greeks were much aware of the work of the Egyptians. And I was thinking of one here, Eratosthenes. This was about, 350 BC. Now, Eratosthenes, he kept a record of what he had done. But he believed, Eratosthenes and Plato suggested it, so too did some of the other Greeks, that the earth is a round object. Now, Pythagoras suggested this, Eratosthenes suggested it, and they got their ideas from eclipses. In other words, as there would be an eclipse of the sun or an eclipse of the moon, and you've all seen eclipse, you know that when the eclipse is taking place, you see a rounded object coming in between the earth or between the sun or the moon. And this led them, some of them, to believe that the earth must be round. Now, many of the Greeks developed a philosophy or a science, if you will, that the earth is flat. And you know, there are people in this country, throughout the world in fact, there is what we call a flat earth society. Now maybe some of you belong to it, I don't know. But there are at least 500,000 people in this country who sincerely hold to a flat earth society. In fact, there was that time when people were afraid to sail out on the ocean for fear they'd come to the end of it and fall off. But yet there are people today. Now, where do they get it? Well, it says, for example, in the Old Testament, that we will travel to the four corners of the earth, north, east, south, and west. It states it right there. Well, if you travel to the four corners, people argue then there aren't four corners here. But there would be four corners if you have a flat earth society. So we can come up with lots of different ideas. Now, Eratosthenes was a definite believer that we had a round earth. And he went over to Egypt because he knew that they had a lot of instrumentation over there. And he did this. Let's say this is the earth. Now, I can maybe make that a little bigger. He said, we do know this, that objects released fall to the earth. And then he believed this, that if he plumbed a line, well, any of you have done carpenter work know that if you take a plumb bob, or just a weight on a string, to make it vertical, we say it points to the center of the earth. So Eratosthenes mounted a stake, and he said, now this is perfectly vertical. So that points to the center of the earth. Now he did this at a town in Egypt called Syene. Then he was over here at Alexandria, and he put a line here, and it's vertical to the earth. So everything, like every stick that's perfectly vertical, we say points to the center of the earth. Or if, for example, no matter where we are, if we have a plumb bob and we suspend it freely, it will point to the center of the earth. Now, Eratosthenes noticed a very interesting thing. Now he's looking at the sun up here, and the sun literally is an infinite distance away, 93 million miles, which is a tremendous amount compared to the size of the earth. He noticed on a particular time of the year, let's say June 21st or some particular time, that the sun at high noon would shine here at Alexandria, and the sun's rays would come directly over that stake, and there would be no shadow cast. It was just right straight down, no shadow. But then if he went up here a year later, when the sun was at this same position, it made a shadow with that vertical stake of about 7.5 degrees. What I'm saying here, if this is our stake, and the sun is shining at Alexandria, there's no shadow. But at the same time of day, up here at Alexandria, it's actually making a shadow of the stake. Now he used this argument. He knew some geometry, and he said, for all practical purposes, this this 7.5 degrees, is going up here to the sun. So those two lines, for all practical purposes, are parallel. Well, if you remember your plane geometry, you say two parallel lines cut by transversal, the corresponding alternate interior exterior angles are equal. So if this angle is 7.5 degrees, then this angle will be 7.5 degrees. Well, we know from our geometry that the full circle is 360 degrees. So 7.5 is equal to 1/50 of 360, approximately. So then he measured the distance from Syene to Alexandria, and it's 500 miles. So if this is 1/50 of the full circle, then 50 times 500 would give us the circumference of the Earth of about 25,000 miles. So he did this about 350 BC. Now, in order to accept this, what I'm saying, you have to go along with Eratosthenes with his idea that the Earth is round. You have to accept the principles of the geometry with which he worked. If you won't accept them, then it's not valid. So as we move in science, here's the biggest problem we have. You have to be willing to accept certain consequences of the experiments that we do. Then if you're willing to do that, we can deduce some logical conclusions from that experimental data. Now, it's a constantly changing thing. And that leads me to say this, that in this history of the Greeks, we have two others that I'd like to mention. Parmenides was another, he was a contemporary of these same people. Now Parmenides believed in a, I'll call it a static situation. There is no such thing as moving. Moving is an illusion. There's no such thing as change. And he developed an entire philosophy on the premise that for you to say something moved, that's something that's a thought process. But things are static. There is no such thing as change. And one of Parmenides' students, Zeno, developed a whole system of paradoxes based on this philosophy of Parmenides, that motion is impossible. Now I'll just mention one, and I'm sure you've probably, Zeno said, let's suppose that we have, I'll say Achilles and a turtle. And Achilles says, now I know, he talks to Mr. Turtle. He says, Mr. Turtle, I can run 100 times faster than you. And the turtle agrees. So Achilles says, I'll challenge you to a race. And I'll give you a start of 100 paces. So here's Achilles, and here's the turtle. Now this is Zeno making use of Parmenides' philosophy. So Achilles says, when we're separated here by 100 paces, whatever that is, we'll start our race. So when they start, Zeno argues, when Achilles gets up here, the turtle will have run 1/100th of what Achilles did, because he can only run 1/100th of that distance. Now, when Achilles gets to this place, the turtle will have run 1/100th of that. And when Achilles gets here, the turtle will run 1/100th of that. And if they run for eternity, Achilles can never catch the turtle, because the turtle will always be 1/100th of that distance ahead of it. So motion is impossible. And you know, that paradox, along with some 8 or 10 others that Zeno laid down, remained unanswered for a long, long, long time. Now, you might say, but I know it moves. In fact, Galileo later on says the earth moves around the sun. And they brought him before the Inquisition and said, you retract. The earth doesn't move. And if you don't retract, that will burn you at the stake, if you will, or take certain inquisitorial action on you. And Galileo says, well, okay, it doesn't move. Now, somebody says it's, whether it's true, we haven't any idea. But on the way out of the examining room, Galileo kept saying, but it moves anyway. So we say, well, certainly we know, even though this looks like a logical argument, we know that Achilles can beat the turtle. Philosophically, we run into some real problems. Well, in order to get around it, another Greek, Heraclitus, does just the opposite. He says the only constant in the universe is change. Everything changes. We're born and we die. It's black and it's white. The earth constantly moves. He says you can never step into the same stream twice. If you put your foot into the river, pull it out, put it back in, some of that water will have moved on. So you can't repeat. You can never relive. Time and time again, we'll hear people say, oh, if I could just relive that thing. Heraclitus says that's impossible. What's done is done. You better put that in the background and live with it. Everything is change. Kettering, Charles Kettering, the fellow gave a lot of the money to build this building, was a great believer in that. He says the only constant in the universe is change. Everything is change. And this would be Heraclitus. Now you might say, why didn't they all get together? Because we can build up some pretty logical arguments here. You can build up some things that make us feel that Parmenides has a pretty sound philosophy. Aristotle, Plato, Archimedes, Zeno, Pythagoras, they all formed certain schools of thought, and they did lecture and they wrote and they kept track of it. So those things have been handed down to us, and Dr. Chesmeyer keeps track of all these in his courses in ancient philosophy and modern philosophy. Everybody develops a philosophy. Bertrand Russell would be one kind, Nietzsche another, Schopenhauer, Hume, all the way down the line. They have a certain concept of what life is all about. We argue and argue and argue. Is there a method? Is there a purpose? Aristotle thought there was a specific purpose. And so we get into a line of thinking, if I can spell it, of teleology. I think I've got that spelled. A teleological concept of life, a purposeful thing. Are we here for a reason? Well, there are some who are very skeptical, who have a feeling that no, we're just here by happenstance. It's a pure chance that we're here. We can develop all kinds of philosophies, and we have that in science. We have different kinds of scientific ideas, and we have to do a lot of evangelizing to get some of them accepted. Those of you who have studied quite a bit of science know that's true. And Max Planck, one of the great scientists of the 20th century, argued that the only way you can get a new idea in science to be accepted is to wait until the old guard dies out. Then you can get the younger generation to accept it. And if you're the younger generation and you accept certain things scientifically, in some years from now, there will be another school of thought, and either you will accept it or they'll push you aside and new ideas come in. This is true in music, it's true in art, it's true in philosophy, it's true in economics. Now the question is, how many of them are sciences? Is economics a science? Dr. Ford would say yes. then why do we have so many different kinds of economic theory? Well, she can come right back at me and say, well then, why do you have wave mechanics and quantum mechanics? Why don't you get together? So it's a never-ending field of change. And the Greeks sensed this. They knew that as time goes on, all of their thinking would play a part in the social structure and the culture to come. We build a culture on it, but it's built on curiosity and on creativity and imagination, this poetic leap of Plato. Well, that's all. We'll finish up with the 17th century on Friday.